Okay, so I'm Ray Fremont Jr., the Director of Marketing for General Air Products. We're going to talk about cold storage air supplies. General Air Products is a manufacturer of air compressors, dry air generators, nitrogen generators. We have accessories like air maintenance devices, and then we also have a line of 13D pump and tank systems. We've been involved in the industry for a long time and expect to continue that. We've been involved in every trade organization stuff. So I like to bring that up because we're of the industry, and I think that that's important because we spend a lot of time making sure that we understand the needs of the industry, and so hopefully we're getting to that in this presentation as well. A little disclaimer here. Basically, the NFPA would like us to make sure that all attendees know, and they do this for everybody, that they want everybody to know that any interpretation of code outside of what they have in the books or that comes directly from NFPA is the personal opinion of the presenter. With that said, too, I mean, we'll be talking about a lot of different things with air supplies, some of them kind of a little different. And what I encourage everybody to do is if you hear something that you think isn't right, doesn't sit right with you, whatever it is, ask the question. My contact information is on the slide. I'm always happy to provide it. And I'm always looking forward to hearing from people. I don't know what it says about me, but I genuinely enjoy talking about air supplies and things like that when it comes to this. And so I'm always happy to field questions. So don't hesitate to ask during the presentation. We'll get to it. And if you think about something after or down the road, you never hesitate to reach out to us. All right, so that's the kind of announcements to start off with here, and I want to get into the what our presentation is going to be about today, and that's what technologies are available for filling dry systems. Then we're going to get into pros and cons of different technologies like air, dry air, and nitrogen, which are the three primarily that are available. I want to talk about system leak rates versus flow. This is really important. Like I said, there's a lot of questions about this type of stuff, especially as it pertains to nitrogen. And I'm happy to answer those questions. We have a pretty good handle on how air supplies operate in the real world in these in these systems, and that's whether it's got nitrogen on it or not. Why is it running? Why is it running a lot? Things like that. There's going to be times where you face that, and we can explain what's going on there and what you could do to mitigate that somewhat. How to determine which technology is best for your freezer room application. Obviously, that's going to be the focus of it. So these first several sections are about providing some background so that we can make that determination better. And I'm hopefully giving you the tools to do that. But again, the main tool that I'll say is General Air. I mean, we pride ourselves on our expertise. I always say we're experts in fire sprinkler systems right up till the air maintenance device. Everything after that, we have no idea what we're talking about. But up to between the air maintenance device and the air compressor, we're pros. And that's really what we want to make sure that we share that with you guys. It's part of what you get out of General Air Products, and I always want people to utilize that aspect of our company. We're the only people who really provide that type of expertise when it comes to these air supplies. So again, utilize our availability and our service from that standpoint as much as it benefits you. So let's get started. Air supply decisions for refrigerated spaces. Very simply, the big thing that we're talking about here is ice plugs. Ice plugs caused by, they can either be partial or fully blockage of the pipe. FM once did a study, this is going back a ways, but I think that it's still important to understand. But after several years of these studies by Factory Mutual found that 50 to 70% of dry pipe systems inspected in freezer rooms and cold storage warehouses had ice plug problems. Now, this is back before the Dry Air Pac, which was about 25 years ago when they did that study. But so I don't know of an update to that study. Hopefully now that people are employing more technology like dry air to that number has gone down significantly. But my point with showing that stat, even though it is old, is that it is important to understand that this can be a real problem. So and speaking of real problems, when it comes to freezer rooms and cold storage, what isn't a real problem is corrosion. Corrosion inside of a freezing space is typically not much of an issue. And I want you to remember that because it becomes important as we move forward and talk about nitrogen. So what causes ice plugs? There's two primary causes, and that's priming water. So over top of a lot of, especially older valves, I think newer valves have less priming water, if any. But older valves, a lot of times that priming water sits on top of the clapper, and as it sort of evaporates, it evaporates its way into as a vapor into the as water vapor into the sprinkler system. And when it reaches the ambient air freezer room interface, the length of pipe that spans those two pieces, it begins to freeze. Same thing with the air or water vapor coming from the air supply unit itself. When you compress air, you get moisture. The moisture that you get is going to go into the system. Now, tanks catch a lot of it, and you can go through a dryer. That's another way, or filters, things like that. Can't recommend doing those enough in these situations, even though an air compressor is an option, and we'll get to that as well. So contrary to popular belief, using air from the freezer room for the dry pipe system will not solve the ice plug problem. So when so it will reduce the problem, but not solve that problem. And again, we're going to get more into that as we go forward, like right now. I always forget what slide is next. Okay, so air supplies for refrigerated spaces defined in NFPA 13. Okay, so if you look at that section, the 2019 edition, you're going to see three options for air supplies. And I want everybody to pay close attention because I'll cop to this here is that I didn't pay a lot of attention to it until recently when we were kind of starting to do these sort of presentations, I want to say a year or two ago. And as I, read it, I was surprised. So please make sure you understand this. So there's three options for air for freezer room, cold storage, refrigerated spaces, as it's called out in the standard. Air from the room of lowest temperature to reduce moisture content. That's the first one that we're going to deal with. I'm going to go through all of these, but reduce is really the operative word here. Understand that if you are using an air supply like standard compressed air, pulling air from the freezer room, when that air gets into the ambient environment and then through the air compressor where air gets heated 200 to 400 degrees on the outlet of a standard compressor, you're going to have some moisture. It is less moisture. Let's say this freezer room's in this refrigerated warehouse is in Florida. If you're pulling ambient air, you're going to get a lot of moisture. If you pull air from the freezer, you're still going to get moisture, just less of it. When you have less, you're still going to get an ice plug. It's a matter of run hours. How often you're going to get an ice plug is a matter of run hours and moisture content of the air that's going in there. So do remember that reduce is the operative word here. You are not eliminating ice plugs by using a standard air compressor and pulling that air from the freezer room. You will get ice plugs, but they will be less frequent than if you pulled the air from the ambient, but you still will get them. So that is option one. Option two, compressor dryer package that's listed for the application using ambient air. So that on the far right is our Dry Air Pac of your screen there. And that's the Dry Air Pac, and that is a listed compressor dryer package. It's FM approved. We're going to talk about it some more. But when the ambient air, now you don't have to, with the listed compressor dryer package, you do not have to put your intake in the freezer room. You can have your intake be ambient because it doesn't matter really how much moisture is in the air as it goes through the dryer package, part of the compressor process there. It's going to remove all the moisture down to what's referred to as single grains of moisture in the, I believe, billionths. The last one that's listed on here is compressed nitrogen from cylinders used in lieu of air. What's important in that sentence, and this is the part that surprised me, seeing so many people, ourselves included at times when customers request it, selling nitrogen generators into freezer rooms, is that the word generator is not in that line. We're going to come back to that, but right now, as far as the standard reads, air or standard compressed air from the room of lowest temperature to reduce moisture content, a listed compressor dryer package, or nitrogen cylinders are your options. Now, that doesn't mean that if you have a nitrogen generator on a system that you need to go throw it out or anything. What it does mean is that you're going to want to focus on the next couple sections when we get to the nitrogen generator part of our presentation here. So let's move along, and we'll keep you going with that. So again, those three technologies that meet that from, and I will say the nitrogen generators should meet it as long as you treat them as air compressors, and that's what we'll get into. But compressed air, nitrogen generators, and dry air generators are what we're going to be talking about today as far as air supplies. I won't really be getting into the cylinders, but I can field some questions on them if you have them, the nitrogen cylinders. There's not much different there other than you would fill with those cylinders is the idea. You would do your 30-minute fill with those cylinders and then have a bank of cylinders available in order to maintain system pressure. So if you want to be spending your time, constantly swapping out cylinders, then that's your business. But that is acceptable. So what types of air compressors are available for fire sprinkler applications? So this is more broad, not so much into just the freezer room, but just what's available. And you're looking at two main types, an oilless piston type air compressor, which you see those styles on the left, and then lubricated reciprocating air compressors on the right. If you look at the bottom right image there, that's a tank mounted lubricated air compressor. And what we do is we add a dryer module to that to make the dry air pack. So if it looks similar, it is. And then this is just showing you how many varieties that there are of these different types, and also a quiet series versions of these as well. So lubricated compressors have their own pros and cons versus oilless. Against oilless, they're of equivalent capacity, and we measure capacity as CFM. Ones of equivalent capacity, you're looking at a lower initial cost typically. Higher system capacity overall because it's more economical to go larger with lubricated units than it is with oilless units. And then another aspect of these that's a real positive, a lot of people take advantage of, is what we call repairability, which, as you can see there, the pump and motor are separate. So let's say, which is one of the most common returns that we get, is nobody changes the oil in the pump. The pump will seize within a matter of weeks. Once the oil runs out, or days, depending on how far along you are and how much the system is running. And at that point, once the pump is seized, you can simply just replace the pump instead of having to replace the whole unit. Same thing if somebody does something electrically funky to the motor, you can have just a motor replacement. On the other end of the spectrum, and all, our viewpoint as a manufacturer of industrial, products, this specifically being for fire protection here, but just all industrial products, everything has pros and cons. Your car, your bike, your refrigerator, everything's got pros and cons. So it's important to learn what those pros and cons are, so that you can have the best understanding of what piece of equipment is going to be used best where. So in the cons department for lubricated tank mounted compressors, they're maintenance intensive compared to oilless. It's one of the big advantages of oilless. So with maintenance, again, we're talking about changing the oil, changing the pulley on the flywheel, the belt on the flywheel, and emptying the tank of water, basic compressor maintenance. But the two biggies are the oil and the flywheel and the belt on the flywheel, and making sure that that's all aligned and that the belt is in good condition. So oilless compressors, so some of the pros there, low maintenance. Now, please remember, I say this again and again, low maintenance, not no maintenance. They still should be looked at. Intake filters should certainly be looked at. That goes for lubricated compressors as well. Just make sure nothing's loose on there, especially in the regards to riser mounting units where you want to make sure that it's stuck to the bracket real well. Our oilless units are UL 1450 VDUR listed, which is the specific listing in UL for fire protection air compressors. Riser configured compressors have no footprint because they're mounted to the riser or the wall or the floor or some sort of cross beam. And reduced cycling. If you have a tank mounted unit, that reduced cycling also applies to tank mounted lubricated units. Negative aspects there, higher initial cost. When you're talking about the same flow out of the two units, the oilless compressor is going to be more. So what's that mean? In a lot of ways, if you're prescribing these, if you're a designer or a engineer, when you're deciding to put something in here, it helps to know if people are going to be on site doing maintenance. In the instance of a freezer room, it's something that typically can be found out, especially, well, there's a lot of factors that go into whether or not they do maintenance on them. But a quick call to find out, what their maintenance program is. Do they hire a contractor to come in quarterly? What do they do to maintain? And if the answer is nothing, we don't know. Well, then oilless is probably a better way to look at. But if, it's not going to last forever that way, but it's giving it a better shot because a lubricated unit isn't going to last for very long. Again, if nobody's maintaining it, then you have oil that's going to run out of the pump, and you're going to have a seized up pump real quick. Again, very, very common return for us. So if we take all these as a whole, as we compare them to the other technologies like nitrogen and dry air, the pros here are very high airflow. So our CFM is what it says on the side of the machine. We're not going through any restriction like desiccant beds or a nitrogen membrane or a molecular sieve, anything like that. We're not losing flow. The flow that you have on the compressor is the flow that you're getting in your system, which is a good thing. Lower initial cost compared to, again, nitrogen and dry air, and long lasting. So, dry air, I think, rivals compressors. Nitrogen generators have a lot of very expensive replacement parts and typically the compressor runs on them a significant amount more. Even with a 2-tank system, they still runs way more than a regular straight up air compressor. But so their straight up air compressor is much longer lasting. Negative attributes across, when we're looking again at air compressors collectively, they contribute water and water vapor to the sprinkler system. So there is a corrosion issue there. And in the instance of refrigerated spaces, there is an issue with ice plugs, as we were talking about. So a standard compressor on its own offers no inherent corrosion mitigation effects. What we're looking at on the left-hand side here is the corrosion triangle. I like this as an explainer for corrosion. There's a couple people out there who talk at length about how corrosion works from a chemical standpoint, and they get into electrons and all of that kind of stuff, which is, as exciting as it sounds. I really like you need to know about corrosion. You left your bike out in the rain and it rusted when you were a kid, right? Well, corrosion lesson over. That's how that works. So now that we know that there's corrosion in our pipes, we need to know how to mitigate it. And the way to mitigate it is lop off one of these points on the corrosion triangle. So in the instance of a compressor, there's nothing that we can remove from there. We're actually adding water. So it's, again, helps create a corrosive environment, but we're also going to apply this to a freezer room. So we're adding the instance of ice plugs from that water vapor going into the system. Before I move on there, a great way to use a compressor as a corrosion mitigator, not so much specifically for cold storage and freezer rooms as we'll get to, but just in any regular dry system is by using, I think, by using AGF's Core Insight, which I believe Jim will be talking about somewhat. The Core Insight product is a corrosion monitor that has a physical activation, which I really like about it. And well, you know what? I'll let Jim talk about that. But for any customer that you have thinking about corrosion, and they're not, and this is on a standard dry system outside of cold storage, and they're not real keen on the cost and they're, or necessarily maybe the technology up front, maybe they've had some bad tries with it or something like that. I think a great way to go is to put compressors on there and then put some corrosion monitors like Core Insight on there, and watch and see. Because once you see corrosion happening, then it's an easy thing to do to say, hey, it's time to put a nitrogen on there, or it's time to put dry air on there, or what have you. But if you don't see any corrosion, well, then the monitors have helped save you a lot of money on that equipment. So something I think it's relevant to bring up there. All right. So again, we were talking about this before. I'm going to come back to it, but air from the room of lowest temperature will reduce moisture content. Again, we're contributing with air because ambient air has water in it, and ambient air is what we're sending into the system. Whether we go through the freezer room or not, there's still going to be some moisture in that air that's pulled in. Like I said, reduces the operative word, and air in the freezer room does have some moisture. Maybe not a lot of moisture, but some moisture. But it's not moisture in the freezer room. That's the part that we need to understand here, right? As those frozen, maybe call it water crystals, things like that, whatever's left, kind of floating in the air, that's going to get pulled into the intake. And as it gets pulled into the intake, it's going to get heated up. So there is some moisture. Again, reduce is what the standard says, and it says that for a reason. Because if it says eliminates moisture content, that would be a different story. So just can't say enough to the expectation. And we see, I would say probably most freezer rooms that we've come across just have a standard air compressor on them. And they wonder why they have ice plugs. It's built into the explanation as to why you can use an air compressor, that you will have ice plugs. So just remember that. All right, let's talk about nitrogen. Air compressors with nitrogen generators on them. Basically, it's a nitrogen generator is an air compressor with a fancy filter on it, a lot of alarms and things like that additionally. But when you boil it down, it's an air compressor with a fancy filter on it. And that fancy filter, when the compressed air comes out of it, will be at 98% nitrogen in the fire sprinkler world. That 98% nitrogen will mitigate corrosion once it is completely through every part of the pipe. So that's what we would call a quantifiable approach to corrosion mitigation. Get the inside of your system up to 98% nitrogen, and you are now should have a corrosion, not free necessarily, but severely reduced corrosion taking place inside of your piping system. The air compressor on a nitrogen generator is going to run much more frequently. I think I touched on that, and that's because we have such reduced flow, and keeping up with the demands of the system is going to cause the compressor to run significantly more. And then, as with all of the air supply things, maintenance is vital. Whether you have just an air compressor or a nitrogen generator or a dry air generator, if no one is doing maintenance, you're going to have a problem. So somebody should be doing system maintenance, unit maintenance, maintenance. Can't say it enough. Really's got to be paid attention to, and I really, there is no such thing from an air supply system, but I would also probably argue from a fire sprinkler system perspective, there's no such thing as a maintenance-free system. All right. So where do we talk about nitrogen here? We talk about nitrogen in this part of the code. We talk about it in regards to a cylinder, which is not a generator. So my first thought after reading that was people should consult with their AHJ regarding the they should consult with their AHJ regarding the acceptability of a nitrogen generator before they put one in the freezer room, because again, these are the 3 air supplies that are called out in the standard for refrigerated spaces and air supplies. So there's no nitrogen generator on there, so you just want to make sure. Like I said, it shouldn't be a problem, and if you ever run into a problem with that and an AHJ, give us a call. But because it's not called out specifically, I just try to give a word of caution there. If it's not a cylinder, it's not a nitrogen cylinder. It's not on the list. So as the standard currently reads, you could use your nitrogen generator in this application. The way that we read it is as as air from the room of lowest temperature. So our read on this here is that if you're going to use a nitrogen generator, you are essentially using it on that list as a standard air compressor. If you are using it as a standard air compressor, then for a nitrogen generator, you must pull the air from the freezer room. So the intake must be coming in from the freezer room and then go through the compressor and then through the nitrogen membrane, which it works fine. But the reason that I say that is, one, this is not a nitrogen cylinder, it's a nitrogen generator. It's also not a listed compressor dryer package. So that leaves us with option one, and option one says you have to pull the air from the freezer room. That's the logic that I'm following. I'm always happy to hear alternative thoughts on that. So if you do have some, please give us a call or we can have a discussion about it. But really, that's the way that we look at it, and there it is. So pros and cons for nitrogen generators. Pros, again, we inhibit corrosion very effectively, especially in systems with poor pitch and little drainage. This is, again, more referring to most most dry systems and pre-action systems, not so much just freezer room systems. Negative here, you have very low flow. The flow coming out of a nitrogen generator is reduced more than 90% from what the air compressor is putting out. That's because it takes time and pressure in the membrane in order to get to 98% nitrogen. And time and pressure are the opposite of flow. So we get very little flow outside of the membrane. Additional maintenance, again, you have more maintenance than a standard air compressor because we have some pre-filters. It's in line with the dry air generator, although the dry air generator has maybe one more maintenance step. And then high cost. So the initial cost of the unit and the parts of the unit are very expensive. So that's a negative aspect of it there in regard to its corrosion mitigation capabilities. From the corrosion triangle perspective, nitrogen primarily works to eliminate oxygen and reduce oxygen in the environment inside of the piping. That's where we're getting most of our corrosion mitigation. But 98% nitrogen is very dry, up to negative 70-degree dew point dry, which puts it on par with dry air. So with water, we are also eliminating some of that, though the flow is so low that it's hard to make an equivalency between generators and dry air there, though the dew point is similar. Even that's not exactly the same. So let's talk about dry air generators. The dry air generators fall under, and ours is called the Dry Air Pac, and they fall under the compressor dryer listed for the application using ambient air. To my knowledge, the Dry Air Pac is the only listed compressor dryer package available. I believe that there are other, I know that there are many compressor dryer packages in the industrial world outside of fire protection, and they can work well, but none of those are listed. So it's something to keep in mind there. So dry air packs were developed actually very specifically for this application about 25, 30 years ago for freezer room cold storage. We were approached by FM, who asked us to come up with a solution because of the significant amount of ice plugs that they had found in their study. We also put them in a lot of parking garages and things like that where ice plugs would be an issue seasonally. They just figured they'd get out in front of it. Now, ultimately, once we started getting into the nitrogen manufacturing, nitrogen generator manufacturing for fire sprinklers, we recognized that the dry air has corrosion mitigating effects, and that if used in certain applications, it can be an economical and effective choice for corrosion mitigation. So that's why we're discussing it here as well. So a dryer is a compressor dryer that removes all the moisture from the air by way of desiccant. I want to make sure, we're going to talk about that next, so I won't get into that right now. So the dry air in the system picks up internal moisture, so like evaporation. So this would be more in standard and standard pre-action and dry systems, where we're trying to basically dry out the inside of the pipe. And that works in some systems over time. We have documentation for that. We have third-party analysis for metals and things like that. That's all available upon request. I believe we have a lot of it on our website, but it is available. If you can't find it, just let us know. We'll send it to you. As air leaves through the leaks or the purge, moisture goes out with it. They provide a level of corrosion mitigation that varies from system to system. So if you want a quantifiable approach, nitrogen's the way to go. If you want to rely on General Air's expertise and understanding of dry air and how we can work with you to find a more economic solution in certain instances, then that's where you give us a call and we might be able to prescribe that. What often happens is somebody sends us a request for nitrogen, and as we learn about the system, we realize that it's a really good fit for a dry air unit, and at that point, we recommend it. And last but not least, maintenance is key. Maintenance. Maintenance has to be done, and the one step of maintenance that has to be done every 3 years is to change out the desiccant. So in those towers right above the compressor, the two, they're DOT tanks essentially, they are each 3-gallon tanks that are filled with desiccant. What happens is, and desiccant is that stuff that's in the those little packets that you see in the picture there that are in all sorts of things where they want to just dehydrate the inside of the box. You know, the example I like to give is beef jerky. You know, whenever you buy some beef jerky, you find a do not eat packet in there. And the whole point of that packet is that, you know, if that dried meat was sitting inside of that plastic pouch for a long time, you know, the moisture in there it's going to get funky inside that pouch. So the idea is that the desiccant is soaking up that moisture, pulling it into it, so that because it's incredibly dry, and it's looking to bring the moisture into it, and it maintains a level of humidity inside of the pouch that's acceptable. Now, what we're doing is similar, not the same, but similar. So the pros and cons of dry air generators: high flow. So as the air goes through the desiccant towers there, there's a purge process that goes on the unit itself to get rid of moist air. So we're putting air through one tower. 90% of that air goes into the system. 10% of that air goes to the other tower. It's dry. The air that's dry goes into the tower, and that goes through the tower to basically regenerate the desiccant and remove all the moisture that's in there. That air gets purged, and then on the next cycle, that tower is now dry. So it is used to provide dry air to the system and the other tower, which this is why they call it a regenerative desiccant dryer, because it's constantly regenerating the desiccant inside of each tower. So high flow is so as air goes through the those desiccant beds, and some of it, about 10% of it, goes out the muffler underneath of the control panel there. You lose about 10% of your flow. So, but still very high flow. Again, remember, an air compressor, you're getting the flow as advertised on the unit. On a dry air unit, you're getting about 10% less flow, and on a nitrogen generator, you're getting over 90% less flow from the compressor. So, just as a quick comparison there. Compared to equivalent nitrogen units, there's pretty good cost savings for especially any systems above 500 gallons. And I'm going to show you some numbers on that towards the end here. They are long lasting. You know, dry air packs can last a long time, a very long time when maintained. They inhibit corrosion best in systems pitched and drained, according to NFPA code. That's one of the big factors that we take into account when we prescribe them as a corrosion mitigating technology. Negative aspects or cons in this equation for dry air generators: additional maintenance. Again, you have a pre-filter, and then you have your desiccant, and the desiccant needs to be changed out every 3 years. It's not every year, it's every 3 years. You can change it more often if you like. It doesn't really need to be, though, but you know, try to remember on your 3-year tests that's when the desiccant needs to be changed out. Just as a point of order there, anybody on this call who has dry air packs or works with dry air packs, we just started a portal where you can register your dry air pack, and you'll get reminders for maintenance when the dry air pack is due for maintenance. So if there is some interest in that, please send me an email right into the comment section that you're interested in that right now. We'll keep track of that and get back to you on how to register your dry air packs. We haven't publicly released it yet. This is actually the first time anybody's talking about it. We're kind of working on it behind the scenes, but it is complete and ready to go, and we're looking for guinea pigs. So if you would like to register your dry air pack with us on our website, we can walk you through that, and I think it'll help with long-term maintenance of these units, as you'll be alerted to when they need maintenance. Negative aspects here. So we were talking about the additional filter and the desiccant, and then it's as far as a corrosion mitigator, it's less effective in systems with poor pitch and little drainage. So if there's a lot of residual water in a system, it's going to take a long time for the dry air pack to dry out the inside of that system. And if that's the case, then you're going to have a lot of corrosion taking place every time there's water, a test is run or water gets into that system. So again, one of the factors that we take into account when we decide on which technology is best for corrosion mitigating in your specific application. So as far as the corrosion triangle is concerned, dry air is, and what we're looking at there is two pictures of other industrial ones, one with a compressor dryer, industrial scale compressor dryer package on the bottom left, and then the top middle one is I believe just a desiccant package where you would add a industrial air compressor to that. And then finally the dry air pack on the far right. The water is removed from the equation in the corrosion triangle. That's what we're trying to do, is remove and eliminate, reduce the amount of water that's inside of the system, and that's going to reduce the amount of corrosion that's going on in there. And it will also, again, as we're putting air into the system in a cold storage and freezer room system, we are putting in air that has absolutely no moisture. And if we have no moisture that we're putting it in through the pipe that's the ambient air freezer room interface, then you should not be getting ice plugs. Flow versus leak rates. Flow of air, flow of nitrogen versus system leak rates. So understanding how CFM affects leak rates, and leak rates affect your air supply equipment. So when sizing a nitrogen generator, one thing that I want everybody to remember real quick is that not everybody offers a air compressor with them. So if you don't have, you make sure that when you're getting a nitrogen quote that you're getting a fill compressor with it. General, we build ours into the unit. Other people offer them separately. It's just something to keep in mind as you're doing this. Sometimes people see different numbers on the quotes for the nitrogen generators, and they go, wait a second, how come General Airs is, more expensive or whatever? And that's because we've integrated the fill compressor, because you're going to need one anyway, and compressors are kind of our thing. All right, so this is the code that calls out this section of the standard that calls out 30-minute fill. That's important to us in this instance because the flow or CFM of the fire protection air compressor is necessary, or it dictates the flow necessary to fill the system. This is basically how we start to quantify flow with that section of code. That's one of the, call it the variables. When using nitrogen generator, or I should say constants. So when using the generator, the next step is establishing what flow will be required from the unit while it's in nitrogen mode. That is where things get a little tricky, and I like to point this out. So as the standard currently calls out, and I'm hoping that this is going to change and be put through on the next cycle. There's some standard changes to the standard that will mandate sizing at the existing system level, but it is not passed yet. So in the meantime, we're still dealing with a lot of people who are looking for or sizing to new system leak rates, which I think is a bad idea. But that said, right now it's something that we're as guilty of as anybody else, because there's a cost difference if between new systems and existing systems. We're going to get into all this. So for the new systems, your leak rate is called out in NFPA 13 as 1.5 psi over a 24-hour period. For existing systems, your leak rate is called out as allowable leak rate is 3 psi every 2 hours for that test that you can run on every 3 years or so, which works out to 36 psi in 24 hours. General and all the nitrogen manufacturers use these points to decide how to size the nitrogen generator. So what you want to remember is, how do you want your generator sized? When you get handed a project form, every project form from every manufacturer says new system or existing system. And the reason they say that is so that we can decide, based on what you checked off, if we're sizing the system for a new system leak rate or an existing system leak rate, because that's going to tell us how much flow we need. And with the existing system leak rate, we need much more flow. If we need more flow, we need a bigger nitrogen generator. If we need a bigger nitrogen generator, it's going to cost more money. This is what we have to keep in mind. But there's a reason that the existing system leak rate is where we should be at. And we're going to get into that coming up here. So a nitrogen generator or dry air generator is an air compressor with a filter on it. We talked about that already. But those filters restrict flow. So that's why we don't see that as advertised. So here's the inside of the cabinet for a generator on the right. In the middle, you can see that's just a tank-mounted oilless air compressor on the back. And that's that gray tube on the far right. What you're looking at there is the nitrogen membrane. So that's basically, it's just a filter like the little blue ones down below, except that's a very specialized filter in that it separates oxygen and nitrogen molecules. So let's take our leak rates through a sample system. The sample dry system that we're going to talk about today is the largest riser is 2,000 gallons. The total number of risers for system pressure on these systems is going to be 40 psi, and the total system capacity of all 4 risers is 5,000 gallons, which works out to about 2,500 cubic feet at pressure. Okay. New system leak rate being 1.5 psi per day. That works out to a flow that we're going to need out of the air supply unit of 0.047 CFM. Now that's maintenance mode, not in fill mode. It's just keeping up with a new system leak rate in a system at this pressure of this size. So in this system, at a new system leak rate, our correctly sized nitrogen generator, again, needing only 0.047 CFM to keep up with the leaks, we need a generator that's going to put out 98% nitrogen at a flow north of that, which is the correctly sized one, if you checked off a new system, would be a 0.6 CFM unit. And that gives us far more than what we need on day one. The correctly sized dry air generator, again, because we don't have a separate air and dry air mode like you do with nitrogen, where you have a separate air and dry air and nitrogen mode. In the dry air unit, it's just dry air all the time, and we have about 20 some CFM for that. And then the correctly sized fire protection air compressor is going to give us about 24 CFM. Now that's just for the compressor, and that's going to, so those two on the right are going to give you your fill and your maintenance. That's what we're going to be using to do our maintenance. On the nitrogen generator, you're going to have that 24 CFM unit plus the nitrogen unit that's now flowing at 0.6 CFM. Now, this is the really important thing to understand, is that just because you have nitrogen on a system doesn't mean your system leaks are not going to grow. It's for anybody with any experience in the industry, it's very easy to understand that your system leak rates are going to grow over time, even if you mitigate corrosion, because corrosion isn't the only thing that causes systems to leak. Valves being left open or not seating properly, dried out gaskets, incorrect gaskets, cross-threaded connections, building use and movement, leaking drains, all sorts of external corrosion, all sorts of things like that are going to cause leaks in systems. Those leaks that are caused by these types of things and so many other things will continue to grow on a system that has 98% nitrogen on it, which means that your leak rate on day one is not going to be your leak rate on year 1 or year 3 or year 5, even if you maintain 98% nitrogen the entire time. So with that said, let's take our sample system out to 9 years and a leak rate of 21 psi per day. At that leak rate, we're looking at about 0.65 CFM, and as what we need to keep up with a 21 psi per day leak rate. And our nitrogen generator that was sized for a new system will no longer keep up because we don't have enough flow coming out of it at 98% nitrogen. You'd have to then switch it to air mode. This is a problem if you have a freezer room and your leak rate surpasses what the nitrogen generator can do. You have to switch to air mode, and now you're putting ambient air. If you haven't pulled from the freezer room, you're going to be putting ambient air into the system. If you pull from the freezer room, you're going to be putting freezer room air into the system, which can be okay, but still not as good as just straight up dry air, as we were talking about before. Now, if we push this system out to the limits of NFPA 13, the allowable leak rate, we're at 36 psi per day. And now, if you had checked off new or existing system is what this is going on, we would have sized it at the beginning at a 1.2 CFM unit because we need 1.1 to keep up instead of the 1.6. I think that's important for people to understand. Correctly sized generator, we're going to be good through this because look, we have 21 CFM that we're using, dry air generator that we're using to keep up with system leak rates. So we can keep 36 psi per day, times 5. We can do that and still keep up without the dry air generator overrunning. Same thing with the air compressor as well. So why haven't leak rates been a concern before now? Well, because we're sizing air compressors and dry air generators to keep up with fill requirements. The maintenance requirements are easy. Now we have a nitrogen generator that has a separate, way of filling the system, and then it does maintaining the system. And the times where you maintain the system, you're doing it at a severely reduced flow. So what do you do when you have a new system generator or any air supply where the leak rates in the system are surpassing the unit's capability to keep up? Well, you can either fix the leaks, buy a larger air supply unit, or in the case of nitrogen, switch to dry air or standard compressors. But remember, think about trying to fix air leaks in a freezer room. It's not difficult is a nice way to put it. It's closer to impossible than it is difficult. Maybe improbable is the right word. It is improbable that you'll be able to fix those. So how do we determine which technology is best? We went over the project form. Remember to keep a good perspective between real world, which I call NFPA 25 as real world, versus design world, which is NFPA 13. You got to think about how the system is going to be a few years down the road in order to have the right air supply solution. So let's get freezer room specific with this application here. So same sample system, same leak rates apply, new system, existing, and the max allowable. These are some questions that we like to ask in order to help people figure out how to determine whether or not they need their, which air supply is going to fit best. So is the system prone to leakage over time? A freezer room system, it's been our experience with dealing with dry air units over the past 25 to 30 years that these systems leak quite a bit. And that makes a lot of sense from the standpoint of it's an in-rack sprinkler system, or if it's an in-rack sprinkler system. Anytime that they're moving things, ice cream, frozen food, whatever it is, on and off the shelves, anytime they're doing that, they're moving and shaking the entire system, and that's going to cause small leaks to appear at a variety of places throughout the system, and that's going to cause the unit to run a lot. So the system is prone to leakage over time, in our experience. How much corrosion do we expect to take place? Little to none. Again, inside of a freezer room, the things that cause corrosion in the corrosion triangle is water, not ice. If you have freezing inside of there, you don't have much or any water. If you don't have any water, then you're not going to have much corrosion. Further, whether it's a refrigerated space or a freezer room space, because it takes so much time to bring the temperature down to where they need it to maintain the goods inside, they are typically, the owners of that business are getting exceptions or just simply not doing any types of tests that involve running water through their pipes. They're not going to decommission the freezer warehouse for a 3-year test. So most times, again, in our experience, most times the freezer rooms get water once, if at all. They get water one time to do a test before they start to turn on the coolers, and then it should never see water again. Well, that makes it a real poor candidate for a corrosion mitigation solution. So it's something else to keep in mind, especially a corrosion mitigation solution that isn't throwing out a lot of flow when the system is going to potentially be very leaky. Is the pipe accessible? Typically, very much so. In places where the pipe is not accessible, again, I'd consider more nitrogen, but the pipe is also very accessible here. But that doesn't really help us a whole lot, or I'm sorry, I consider dry air, but that doesn't help us a whole lot, the accessibility of the pipe, because even though we can access it from a physical standpoint of like it's right in front of us, addressing the air leaks in it is not easy. Which is the next question in there. Can you find the and repair the air leaks? It's difficult to impossible. We'll talk a little bit more about that in a moment. What's the intended life of the structure? Again, if you have a short-term kind of structure, what are we talking about? 60-year solutions for your pipe. If this building's only going to be around for 20 years, the pipe should last that long. That said, a freezer room and cold storage warehouse typically is a long-term type of facility. When they build them, they're not looking to knock them down in 5 to 10 years. Is the maintenance routinely performed? Typically, like we've talked about before, typically there's a lot of maintenance done, and that's a good thing for any of the air supply solutions. I'm going to fly through a couple of these because we've sort of talked about it in some of the other slides. But the first one I want to start with is that water generated by a standalone air compressor will cause an ice plug eventually, even if it's pulled from the freezer room. I know I've said it a bunch of times, but I think it's really important for people to understand. So that's why we would not recommend using an air compressor in a freezer room. So is the system prone to leakage? Again, because of the excessive amount of leaks in freezer rooms over time, a generator size for a new system leak rate, that is going to be overrun by leaks in some short amount of time. It's going to cause you to have to upgrade your nitrogen generator, which is an expensive process. Same thing with the existing leak rate. You see the disparity between 1.2 CFM and 21 CFM or 24 CFM. That's a big difference. So keeping up with those leak rates is a challenge for any size nitrogen generator. I mean, the largest generators on the market only get out about 4 CFM. And that's the largest ones. They're incredibly expensive. They're overkill for a 1,000-gallon system for sure. And we'll do a price comparison in a minute, but that leaves us with the dry air unit. And I mean, I've been building towards this, but the dry air unit is going to be your best bet for freezer rooms every time. I got to tell you, as far as our outlook on all of the air supplies that we manufacture and sell, there's not too many applications. Frankly, this is the only one that I can think of, freezer rooms and cold storage facilities, where dry air or one technology is always the clear choice. Outside of that, it really varies from building to building, no matter the application or type of building. I mean, there's some that, kind of focus more on one than the other or whatever. But, I mean, I wrote an article called Why I Would Never Put a Nitrogen Generator in a Freezer Room, and I stand by it. The dry air is the way to go, I think, in any and every freezer room. And I keep saying I'm going to get to this cost, so I want to show you the cost analysis too. And this is another reason why. Now, notice that in 500-gallon systems or less, the Dry Air Pac is several $1,000s more. And if you tell me, hey, I have a freezer room system that's 500 gallons or 480 gallons, what should I use? My answer is still going to be the Dry Air Pac because it's the right technology. I know that it's more expensive in those instances, but most freezer room and cold storage facilities are much larger. But if you do run into them in that smaller one, I'm still recommending the Dry Air Pac just from performance standpoint. But once you get over that, you start to realize pretty significant cost savings. Once you're into the 1,000-gallon and 2,000-gallon range, you can see that the MSRP on these is much, there's a lot of disparity on the side of in favor of using a dry air unit anyway. And that's where most cold storage and freezer rooms come into play. So not only, this is where I tell everybody is take advantage of these few times in life where the best solution is the less expensive solution. That doesn't happen a lot. So so do kind of keep that in mind as well. The cost should be there, but always kind of do a cost comparison. But even where it's more expensive in this application, I would still say, in the rare times that it's more expensive, I would still say use dry air. And again, this is just the pictures, or I'm sorry, the questions and a list of those questions that we ask. And these can be applied not just to freezer rooms, but across the board to help round out a decision on if the facility or the building is going to be a good fit for which type of technology. And this is what we try to walk people through when they contact us to say, hey, help me figure out what I should do here. You know, we'll be asking you these types of questions so you can ask them yourself. Additionally, talk with anybody involved with the job, the general contractor, the building owner, the installing contractor, anybody that you can, to get a better sense of what this building and what's going to be going on in and around this building. I want to put a quick plug in for our fire sprinkler system training center. Even though we're not doing much in-person training right now, we will do some small private kind of classes. Like if you want to bring your group in with, you know, something like 8-10 people, we can certainly accommodate that, and we can put on with all of the vendors that you see listed there. We have a full room, so I encourage you to go to training.generalairproducts.com to watch our video on our training room to see what we have in there. We have a fully functional fire pump, backflow, 40-seat classroom, although right now I think we're maxing out at 16 for COVID. We have all of obviously our air supply stuff. AGF has a setup in there with every bit of their piece of equipment, and they're right down the road from us, so they come in to present alongside with us a lot, and it just works out great. It'll be a really good long day of education if you want to do that, and hands-on, moreover. There's my email again, and the 800 number. Please use that. I encourage that anybody out in the field to use that. But otherwise, thank you very much for attending today. We genuinely appreciate your participation. We really appreciate your business. General Air is my family's company, so like I said, we always say we take this personal. It's really important to us that we're doing a good job for you, and very appreciative of your business and your participation. So thank you very much. Reach out with any questions. Thanks again. Have a good day.